Hi, I'm Alistair, and in this video I'm going to show you how to use Node-RED and QLC together, two fantastic bits of open source software to create an event-driven automated show control system. So this is a great system to consider if you're building something like an escape room, an interactive theatre or museum installation, a themed attraction, or anywhere you need to apply logic to sensor values and other inputs to trigger lighting, sound or special effects. Now, I've talked about various ways to use Node-RED and DMX control in some of my previous projects, but I think this is the most powerful setup I've used yet, and it rivals the functionality of some pretty big name systems that cost tens of thousands of pounds, but this is completely free. Now, a lot of traditional show control software is built around a queue list, and this works brilliantly for theatre, concerts or timed shows where events happen in a linear order, Q1, Q2, Q3 and so on. And those queues might be called by a stage manager or they might be synchronized to a time code. But interactive projects don't really work like that. In an escape room, players might solve puzzles in a different order, or visitors might take different amounts of time to move through an exhibit or section of a theme park. An experience might branch along different paths depending on what the audience do. So if you want to automate an experience like that, that's where Node-RED can be really useful. Node-RED is a general purpose graphical programming tool, and instead of following a fixed queue list from top to bottom, Node-RED lets you define a workflow with actions driven by events. And those events can interface with loads of different inputs and outputs, pretty much any communication protocol you can think of, providing the connecting glue and control logic between all sorts of devices. Now, you can use Node-RED to calculate and send DMX data to control lighting fixtures directly. And I've demonstrated that in projects in the past to control ambient lights and simple special effects. But if you want to do something more complex than just setting RGB colours, it can become a bit awkward. You end up manually assigning each individual DMX channel value, writing your own fade logic, building your own chasers, and solving problems that lighting software already solves properly. So that's where QLC comes in. QLC is dedicated lighting software. It's used in theatres, concert venues, by VJs and other settings. Now, unlike Node-RED, which is generic control software, it's specifically designed for sequencing lighting fixtures. So it talks DMX, ArtNet, SACN, and it uses common lighting terminology like scenes, fades and chasers. And as well as having a graphical user interface, it also exposes a web interface, which means you can call its functions from another device on the network. So the key idea in this project is that we're going to use Node-RED to define our main control loop. It can poll sensors, apply logic rules. I'm going to use it in an example here to read the value of some RFID tags. And then to trigger a lighting change, we'll have Node-RED make a call into QLC via its WebSocket interface, handing over responsibility to a more suitable dedicated lighting engine. So rather than Node-RED having to calculate a fade or chase or flickering, it simply says QLC change to this scene, and QLC takes over from there. So let's get on with it. Okay, so let's start in QLC+. Now, I'm using QLC version 5.2.1, which is the latest version at the time I'm recording this in May 2026. It looks quite different to the previous version 4. It's been redesigned to make the UI more streamlined for use on touchscreens and tablet interfaces. So one thing I recommend is that if you want to watch any more tutorials about how to use QLC+, make sure that you're following a tutorial that uses the same version as you are, otherwise you might get a bit confused. But we're going to start here at the input and output section. So this is where we define the hardware and the method we'll use to control our physical lighting fixtures. So I'm using a simple DMX USB dongle that can control a single universe of 512 channels of data, and I've got that mapped as the output of universe 1. But if you wanted to assign a different output instead, let's say you've got a lighting fixture that listens to an ArtNet interface of Ethernet, or maybe a SACN interface, you could simply drag one of these outputs instead and overwrite the output of universe 1 there. You'll see that I can actually define multiple output universes as well. Here I've got universe 4, which is actually going to an SACN output at the moment. Now, if you want to get rid of that, you could simply drag the output here and drag it into the trash can at the bottom. But to be honest, these are not actually doing any harm, so you can just leave them if you want. We're not going to make use of any additional universes. Now on the left hand side, this is where we would define any input hardware. So let's say you had a lighting desk or a MIDI controller that you wanted to use as an input into this universe. You would drag the corresponding input channel into the slot here, just as the output. We're not going to do that in this case because our universe of data is going to be controlled via network messages received from Node-RED. So we're not actually going to define any input fixtures on this screen. Instead, we're going to hop over to the fixtures and functions option at the top here instead. And then there's several different views you can have here. I'm just going to switch across to the universe view, and that's going to give me a grid that shows all 512 channels of data in my universe, which is universe 1, and you can see at the moment these are all blank. So what I'm going to do now is to patch in my lighting fixtures. So if I come over here and click on the plus icon next to this light here, you'll see that QLC Plus comes with a load of different profiles for different lighting manufacturers and different models. If I scroll down here to the bottom, so I am using some of these ZQ1496 cob lamps. So I'm just going to drag that profile into the first available DMX channels, which are channels 1 to 8. Now, I've actually got 2 of these fixtures on either side of my setup, but I'm going to be controlling them together all the time. So I'm only going to assign one profile here, and then I'm going to set them to listen to those same DMX channels 1 to 8, so I can control them together. Now for my moving heads, which are in the middle, those are manufactured by B-Topper. They're called LM70s. And again, I've got 2 of those, but this time I want to be able to control them independently, to be able to set the pan and the tilt on them separately. So I'm going to take that same profile and drag it in twice. So one of my moving heads is listening to DMX channels 9 to 17, and the next one is going to listen to DMX channels 18 to 26. Now, if you want to use a lighting fixture that isn't already on the list here, that's fine. You can define a new one by clicking this plus button at the top. Or alternatively, you can find something that's similar to the lighting fixture you want to add. So if you wanted to add a power can or a dimmer pack or an LED tape, you could find one by a manufacturer that's similar to what you want, and then click this button here to edit the fixture definition. This will just tell you that it's going to create a copy of that profile rather than overwriting the built-in one. And you can see you can define how many DMX channels of data it receives, and also what functions those DMX values control, whether it's an RGB or it's got a strobe or an effect or something like that. And now I've got my fixture addresses set up, the next thing is to actually define a few lighting functions. And to do that, we're going to come over to the simple desk view here. So the simple desk has these sliders that represent all of the channels of DMX values for the universe, which I've got selected up here, universe 1. And because I've told it what fixtures I've patched into those DMX channels, you'll see it's actually written some icons at the top here to help represent what they stand for. So here we've got a left-right arrow, and if I adjust the value sent on that channel, you'll see that that controls the pan of one of my moving heads. And the other one is controlled by this pan channel here. Then next to that, we've got the vertical tilt, which I can adjust as well. And then we've also got things like the RGB color values for each of those, which I can turn on. But there's a mode button here, that's what the star is, because you can see that I actually assign different effects and the modes that these RGB values are interpreted. So I also need to put that on to make the RGB values have any effect. So what I'm going to do is to define a couple of scenes using my fixtures here, basically presets that I want them to move to. So let's create a simple red scene to start with, for example. So I'll put both of my spotlights on and I'll give them a little bit of red hue like that. And let's just keep it nice and simple, that'll do for now. Then you see there's a button up here that says the number 4 at the bottom, and it says dump DMX values onto a scene. So when I click that, you'll see that it allows me to save the channels of data which I've assigned in the simple sliders here and put them on a new scene. So let me just call that scene red spotlights, let's say, something like that. And I can define whether I want to dump all of the available channels here or to only select certain fixtures and which channel types to include in that. I'm just going to include everything, so we'll save that. And then once I've defined that, let's define another scene instead. So we'll kill those values. Now let's put our side lights on. So for that, I've got a master dimmer channel here. So let's put that up a bit. And then I've got both pure white and kind of orange or amber light, natural lights for each of those as well. So we'll just put that on and we'll save this as a new scene as well. So we've got 5 channels affected by this scene. We'll call this white side lights, let's say, and we'll dump all of the channels for that. And then finally what we'll do is we'll do something, well, we actually need to move our moving heads, of course, we haven't done much with them yet. And let's put them on as well. Let's make them sort of bluish color or something like that. And we'll put our side lights on as well, so give those some value there. Maybe a bit more distinction there. And we shall save that. And we'll just call this full on or something like that. So you can think of this as a scene-based approach to defining your lights. You could have each of these different lighting states that you might want to have during your experience. You might start with a pre-game briefing with the house lights up, then maybe a warning light gets triggered. You might have various visual cues and spotlights that highlight objects and special effects during a triumphant ending scene, however many you want. But unlike a simple state machine, these scenes can be layered and combined and triggered independently. So now to test our new functions out, I can come over to the fixtures and functions page again and click this button up here to view the functions we defined. So these are our 3 scenes. And then if I click on the red spotlight scene to highlight it, I can preview that by pressing the play button at the bottom here. I can stop that scene and then I can test out the white side light scene instead, turn that off, and the full on scene. Perfect. Okay, and I always recommend testing scenes and functions in QLC Plus first of all, because you really want to know if something doesn't work properly. Is it a problem with the interface between Node-RED calling into QLC, or is it a problem with the QLC function itself? But these seem absolutely fine. So now we need to enable a way for Node-RED to talk to QLC Plus. And to do that, we're going to come to the Actions menu here and go to the Network Server Setup option. Now QLC Plus supports 2 different sorts of servers. You can see it's got a web server and a native server. Now the native server will be to talk to another instance of QLC Plus, but we want to start the web server up here. So if I select that and then click Start Server, and you'll see that it is now running. And that means that it's now listening for a WebSocket input and is able to launch these scenes here, as well as any other functions that we've defined in the QLC Plus workspace, remotely by an incoming trigger signal. So that's all the setup we need to do here. Now we're going to switch over to Node-RED. So I've started off with an empty flow here, and I'm going to insert an inject node. So this represents the incoming event which is going to kick off the flow. Now in a final product, this could be an MQTT message received from an ESP32, a GPIO input on a Raspberry Pi, a serial message, a timer, a dashboard button, whatever. For now, I'm just going to keep it simple and use an inject node, which you can manually trigger here to inject a payload and to trigger the lighting queue for testing. So what we're going to need now is the WebSocket output that is going to send the payload of that flow through to QLC+. So we go to the network section here. You can see I've got a WebSocket out. I'm simply going to connect those two together. Now if we go to edit the parameters of the WebSocket out, you'll see that I'm going to connect to, and then I need to supply the URL of the QLC+ instance. Now, both QLC+ and Node-RED are relatively modest in their requirements, so it's perfectly possible to have them on the same computer. That's what I've got here. So the IP address I'm using is just the local loopback IP address 127.0.0.1, and it's on port 9999. If you have set up QLC+ on another computer on your network, obviously you can change the IP address and port there. We're using the WebSocket interface, and then the endpoint is QLC+ WS on the end. And what this is going to do is that this WebSocket output here is going to receive any payload that is calculated through the Node-RED flow and ends at this node here. So the only payload at the moment is going to be coming in from this timestamp that we injected at the beginning. But we don't want to inject the timestamp. That does make a whole lot of sense. What we're going to do instead is set a string, and the string is going to be equal to the command value that we want QLC+ to execute. So the most basic command structure is to start off with QLC+ API. That tells it we're going to call a function from the API. Then we name what function we're going to call, and I'm going to call the set function status. And then we need to give the ID number of the function that we want to address. Now we created 3 functions in QLC, our 3 scenes. So they're going to be index based so they're going to be 0 index based. So if we say we want to set the status of function 0 to 1, what that means is we're going to enable the first scene. So if we do that, and then I deploy that workflow, ignore the errors here, that's from other stuff in the background. And what I can now do is I can click this button to inject that node. It sends the payload through to the WebSocket node here, and that delivers the value to QLC+, which has set our lights. Now what I can do is I can take a copy of this node here and paste it again. And this time I'm going to edit that payload to deactivate the 0th function. So unsurprisingly, you can probably tell if we wire that to the WebSocket output, click deploy again and hit that, we can now cancel the running function. And I can duplicate that again and again, and I can change the values here to enable and disable our second scene and our third scene. That, connect those all up to the output node that's going to go to QLC+, deploy our changes, and now I can go down the line in order and I can enable each of the scenes individually, and then I can disable them again. So that's a very basic workflow that calls one of the QLC API functions that set function status, but there's some other ones you can use as well. Now I've got a slightly more complex workflow here. So one thing you can do is you can set the values on that simple desk output I showed you. So this sets the value of channel 1 to 255 or the value of channel 1 to 0. So this is the equivalent of sliding that slider all the way up or down on the simple desk. You can also activate what's called virtual console widgets. So this is a function I didn't show in QLC yet, but if I switch back to it, you'll see that there's something here that says virtual console. And what this lets you do is you can drag widgets in, you can drag sliders, you can drag pads and knobs and things like that to recreate a lighting desk, a soft lighting desk. And you can assign functions to all of these values here. So this could move some two-dimensional axis or change the output of a projector. You can trigger special effects and change intensity. You can have a cue list, as I mentioned about theatre cues with particular timestamps or cues. And then from Node-RED, you can simulate an input on any of those virtual console widgets by specifying the ID of the widget. And again, so if it's a button, you can press it by sending the value 255, or you can release it with 0. Or you can set a slider value to halfway if it's 128. Now, in all of these examples here, I've mentioned that you need to refer to a function by its index number. So here we were activating the 0th scene, and here we can set the widget by its ID. Now, in our very simple scene that we set up here, we only had 3 functions, which are our 3 scenes. So they're index 0, 1, and 2. As you add more complex functions, you're obviously going to get a lot more, and it keeps a bit harder to keep track of them all. So I've just added 2 helper functions at the bottom here, get functions list and get widgets list. And then over in this section of the flow, I'm receiving the response from calling these API functions, and I'm just putting them into a dashboard widget. So if I go to the page there, you'll see that I've listed now the functions and the widgets available. And then you can take this workflow that integrates with QLC Plus and integrate that into part of a wider workflow that controls an entire experience. So here I've got a workflow that reads an RFID tag from an ESP32. And when a card is read, it publishes the tag ID as a message to an MQTT server into the QLC topic. So Node-RED subscribes to that MQTT topic, and when a message is published, Node-RED triggers different functions depending on the tag ID. So using QLC Plus together with Node-RED allows you to separate out the game logic from the lighting and effects logic. This approach is much cleaner than scattering hard-coded DMX channel commands in your ESP32 or Arduino code. And it also makes the system easier to develop and maintain. You can change the aesthetic look of a scene, adjust the lighting or add effects in QLC Plus without changing the node logic, or you can change the logic of the game flow without risking or having to rebuild your lighting scene. And while this allows everything to be automated, you can also include manual triggers or overrides that an operator uses from a dashboard. So this can become your complete theatrical room control software. So that just about brings me to the end of this very introductory video to using QLC Plus and Node-RED together. They both have a load of functionality that I didn't demonstrate here, but it's definitely worth checking them out. I'll make the QLC workspace and the Node-RED workflow I demonstrated available for download on my Patreon page, but I absolutely encourage you to experiment because there's a lot more than you can do with both of these pieces of software than the basic example which I showed here. But please ask if you do have any questions or comments on the video below, or you can join the discussion on the Playful Technology Discord server, which I'll also link to. Other than that, I just want to say thank you all very much for watching, and I look forward to seeing you next time. Okay, cheers, bye.